Hello everyone. So in this segment we are going to develop some general principles about social network and their evolution. So here we are going to talk about a very interesting principle known as triadic closure. So this principle says that if two people in a social network have a friend in common, then there is an increased likelihood that they will become friends themselves at some point in future. So what it says that say let's say B and C have a friend A in common. Okay, so it means that A has a friend B. So A has a friend B and A has a friend C. Okay, so this is more likely that at some point B will know C and there will be an age, there will be a tie between B and C. Okay, so we refer to this principle as a triadic closure principle. So if the nodes B and C have a friend A in common, then the information of an age between B and C will produce a situation in which all these three nodes will come to know each other. Okay, and they will have edges connecting each other. So they will form a structure known as a triangle. Okay, so A knows B and A knows C. So at some point this information will flow and B will know each other and they will form a structure known as triangle. Okay, and this term, that's why known as triadic closure, from the fact that BCH, the new age, BCH has the effect of closing the third side of this triangle. Now if we think about that, why the triadic closure happens, okay, the reason is actually very intuitive. All right, so the triadic closure, it's just a very intuitively very natural, and essentially every one of us, I think, will find that from our own experience. So if B and C have friend A in common, how the triadic closure can happen, why it is more likely? So the first reason is obviously B is more likely to meet C, because I mean they both spend time with A. Okay, so B spend time with A, C spend time with A, so this is more likely that B will more likely to meet C at some point. Okay, so B will know about C from A and C will also know about B from A. Okay, so this is more likely that at some point they will know about each other and they will meet with each other. So another reason is that B and C can trust each other. So B and C both has a common friend, so obviously they will trust each other. So they will at some point they will actually can grow the friendship and they will have a tie. And the third reason is A has incentive to bring B and C together. So if A has a friend B and A has a friend C, now let's see, these are I'm talking about, this is two strong network or strong friendship. So A is strongly friend with B and A is strongly friend with C. Now it is going to be actually hard to maintain these two distinct relationship. So at some point think about that A is having some party. Now A is not going to make a party just for B and another party, just a totally different get together for C. So when A will arrange a get together, so this is more likely A will actually invite both of them. Okay, so A has actually incentive to bring B and C together. Okay, so this is going to be actually easy to maintain two relationship. So then B and C will get to know each other and they will form this triadic closure. This basic role of triadic closure in the social network has motivated one very formulation of simple social network measure. So this measure is known as clustering coefficient. So this is one of the measure that formulate the structure of the social network. Okay. So what is a clustering coefficient? The clustering coefficient of a node A is defined as the probability that two randomly selected friends of A are friends with each other. Okay. So the clustering coefficient of a node A is defined as the probability of two randomly selected friends of A are friends with each other. Okay. So how to find the clustering coefficient of a node A? So before that, we should say that this measure is actually it's a very important formulation of the structure of the social network. Okay. Now let us see the examples of the node A. The clustering coefficient of node is 1/6. So what it says that A has here 4 friends, B, C, D and E. Okay. Now if we randomly select two friends of A, okay, if we randomly select two friends of A, then what is the probability that these two randomly selected friends are friends with each other? Alright, so if we randomly select B and E, then what is the probability that B and E are friends? Okay, or if we select C and D, what is the probability that C and D are friends, or C and B are friends, or D and E are friends? So this is the measure of clustering coefficient. So how actually we are going to find clustering coefficient? So let's see in this example, A has 4 friends, B, C, D and E. Okay. Now in a graph, if we have 4 node, okay, if we have n node, a graph with n nodes, the number of possible edges in n node, the number of possible edges in a graph with n node is n minus 1 by 2. Okay, so we can consider all the possible pair with all node. Okay, we can consider all the possible pairs of the node. So this will give us the number of possible edges in a graph with n node, which is n multiplication n minus 1 by 2. Okay. Alright, so here A has 4 friends. So if we just consider a graph with these 4 friends, so let's consider a graph with B, C, E and D. Okay, now what is the possible number of edges in this graph with this 4 node? So this will be 4 multiplication 3 by 2, which is 6. Okay, so so if we consider 4 friends of A, all right, 4 friends of A, there is at best there could be 6 edges, 6 relationship between 6 edges between these 4 node. Okay, so let's draw the graph with all edges that is possible in this graph. Okay, so B can be connected with 3 of them, so D can be connected with 3 of them, so 1 2 3 4 5, and C can be connected with E. Okay, so that is the all possible edges, all edges that is possible in this graph. All right, so number of possible edges in a graph with n node is n multiplication n times n minus 1 by 2. So we are considering actually every possible pairs. Okay, so what it means that A has 4 friends, B, C, D and E. Okay, so that means at best there could be connection between these 4 friends. There could be 6 connection or 6 friendship possible between these 6 friendship is possible between these 4 friends, 4 friends of A. Okay, now let's see how many friends are there are. Okay, so in this graph, what is the friendship, what is the connection between what is the number of connection between these 4 friends of A? So seems like there is only one connection between C and D. Okay, so there is only one connection, there is only one friendship between C and D. Okay, now so the clustering coefficient of node A will be defined as 1 by 6. Alright, so let me say the definition again. So the clustering coefficient of node A is defined as the probability that 2 randomly selected friends of A are friends with each other. Okay, so for the node A, we'll consider all of his friend, and we are going to find what is the number of possible friendship can there be between 4 friends, which is 6, and what is the number of friendship is there between these 4 friends, which is 1. Okay, so 1 by 6, clustering coefficient of A is 1 by 6. So a clustering coefficient of a node I can be defined as, so this is our formal equation. Okay, so of a node Ci, it can be defined as here Ei is the number of edges between the neighbors of I, and K is the number of friendship. Okay, K is the number of friends of node Ci. Okay, so let me go back to the example. So A has so we are only focusing on A, B, E, C, D. Okay, so here Ci is A, so the clustering coefficient of A is 2 of 1, Ei is 1, so only C and D. Okay, so Ei is the number of edges between the neighbors of I. Okay, so we have only one the number of edges between the neighbors of A is 1. Alright, and K is 4. Alright, so Ki is 4, so the clustering coefficient is 2 by 4 multiplication 3, so which is 1 by 6. Okay, so let's here spend some time, and let's here we have 3 examples, and let's find out the clustering coefficient of I in this 3 graph. Okay, so we are going to find out clustering coefficient of I in this 3 graph. Okay, and we are going to talk about that in our next segment.